3D arts for games. This is going to be an introduction. You quickly notice that every subtopic of this presentation could be its own whole class in itself. So first of all, who am I? As Lauren said, I am a fellow Coven graduate from last year. I'm also a digital arts and animation graduate student. Well, no, I'm not longer a student. And I'm currently working on an outsourcing company, and we do 3D modeling for AAA companies. I, of course, love video games, tabletop games, art, and just what as that says, I'm just like a really artsy nerd. Oh, by the way, everything you type, I have a screen here so I can read it. So feel free to type any questions or anything. Now, I did say that because I would love you folks to tell me about yourselves. You're clearly interested in this topic. So I would like to know how much experience do you have in 3D? If you don't work, maybe not necessarily for games, but maybe school assignments, or maybe you do it as a hobby, in order to know what you know if you know a little bit about 3D, or if it's more like oh my gosh, I do not know anything, but I love video games and I love art, and I would love to know how everyone kind of does things. Okay, Lauren says that a tiny bit. Oh, a student in art and technology, nice. I've tried to learn a bit about the workflow. Yeah, we're gonna touch that topic a little bit. Okay. It's okay if you don't have experience. It really is. YouTube tutorials. I know a little bit more about 2D. Okay, excellent. Mainly to the artists. Oh, that's nice. Okay, I'm gonna go to our next slide. Okay, so why do we focus on modeling for games? What's the difference? What's so important? What tells us apart from other stuff? There's other media that uses 3D art for their stuff, for example, VFX and animation. However, there's an important distinction between our needs and their needs. And usually that boils down to something called real-time rendering and offline rendering. If you've done 2D, if you've done animation, or anything that you present as an static picture mostly, you probably know offline rendering. That is when you model something and you have your whole scenes and everything, and then you send it out to your software or whatever, and it gives you back like a picture, such as a frame for Moana. And I added this because I want you to pay attention to how many little lines we have in there. Those are the polygons. I want you to pay attention to how many we have here, okay? Since offline model rendering doesn't need to run in real time, they're able to give more densities to the stuff. Density, it means that you have more polygons in the space. Now, real-time rendering is what we do in games. What we're trying to do is to tell the computer to give us those pictures as time goes. And it's not just, when you're playing it, you're not just like watching like a pretty thing move, or you also need to input commands. You also need to, the computer or your console or whatever also need to check for the inputs and maybe give you sounds. particle effects, and a lot of stuff. So what we're trying to do is basically not to make your computer or console explode by having all of that working at the same time. So how do we achieve this? This is no secret. I want you to pay attention. I mean, it's a bit of an unfair comparison because Assassin's Creed 2 was released way back then, and Moana is a bit more recent. But just look at how many polygons we use to make Ezio look great in game versus how many Moana needed. Yeah, that's all the polys they use. There it is. It's like we usually use trees. I'm gonna go into that a little bit later. They only needed 6,000 versus I don't know how many Moana has, but I think some of the strands in her could probably have that. Now, in order to do this, we use this workflow. I'm sorry, my dog is making a little bit of noise. We use this workflow basically, which is the high poly to low poly workflow. And this is the steps we take. I'm gonna take you through some examples later, so it is a bit more clear. So first you have a concept, or maybe you have a reference picture of what you want to model. This can be literally concept art from the concept art department. This can be just like, oh, I'm gonna model, I don't know, a light bulb. So you go out and search pictures of light bulbs. Then we go into the high poly version of our model. In the high polish, you don't care about density. You are not aiming to have that small amount of polygons or triangles, actually. You just want them to look great. So you spend your time working on it, making it look pretty. Then what we do is, you can also sculpt in here. If some of you know ZBrush or something, you can also use that in here. You go bananas in here. We don't care about optimization. Then we grab that model. We usually do this thing called retopology in order to get that smaller amount of polygons. And then we transfer via baking the data from the prettier and more detailed model to a more simpler one. And then we go into texturing. Some people add an extra step for lighting, but what happens after texturing depends a lot of what you're doing and the particular need that prop has. Maybe you just want to present it, then you do go into lighting and in another software and just present it or render the image. Maybe you just want to get it into Unity or Unreal Engine, then you just send the model over there. So here are some examples. What I want you to focus on is that even though we can see here the mesh, this is from the Spyro Reignited trilogy, this is more recent, is even though we have no actual details on the mesh, they are in here. And that's because we had a higher poly baked in. The same thing in here. All of this detail does not get lost when we baked everything into the lower poly version of it. And these are other examples of models. This one is a prop. I think it could be optimized in other places. For example, I see a bit too many loops in here. So this is all about the optimization. That's what we focus on usually in following silhouettes, for example. For example, keeping silhouettes clean while using the least amount of trees is really important. Here's another example. This is the traditional pipeline, as he says, high poly, then it's baked. So what are we going to do today? We're going to try out a really simple version of this with something called floating geometry. We're going to make a die. So by using some some really simple, well, we're literally gonna make a simple cube, like the simple Blender or Maya cube, or whatever software you wish to use. And we're gonna make it look like it has the little holes in there and indentations. So in the end, we're only going to use 12 trees for something that would use way, way more.